Hello Math 7 students, this is Utah Middle School Math Project 4.1a on equivalent ratios. This is a review of 6th grade material, and this is part 3 in our 3-part video series. You might remember from our previous lesson, we practiced finding equivalent ratios. We realized that when we're finding equivalent ratios, whatever I do to the top, I need to make sure I'm doing to the bottom. So here, I multiplied by 2 on the top, 2 times 2 is 4, and I multiplied by the same number on the bottom, 6 times 2 is 12. Here we chose to multiply by 6, but whatever we do, we need to make sure we do it to both parts of that ratio. In our last video, we had this problem talking about the ski club. We had the ratio of girls to boys, and even though the problem wasn't listed, I did ask the question, is this a part-to-part ratio or a part-to-whole ratio? Answer the question now. Raise your hand to share. Is this a part-to-part ratio or is it a part-to-whole ratio? Thank you. Kaden. It is a part-to-part ratio, and we know it's a part-to-part ratio because girls are part of the whole club and boys are the other part of the whole club. Again, we can see that the first problem asked us to simplify the ratio. So we took the original ratio of 4 to 16. We can simplify it by dividing out what the numbers 4 and 16 have in common. At first we saw that 4 and 16 had a 2 in common, so we divided out the 2. And we got to this place here, 2 girls and 8 boys. And we realized, hey, they still have something in common that I can divide out. They have another 2. So we divided out that 2 again, getting us to 1 girl and 4 boys. And that was the simplest ratio. We also practiced finding specific ratios, like if there's 4 girls, if there's 2 girls, how many boys would there be? And we say, hey, this 4 can change to a 2 by dividing by 2. So since I'm dividing by 2, I'm going to want to make sure I also divide the 16 by 2 and get 8 boys. That's your quick review. Now it's time for you to work on your own. This is what's going to happen. We do have 2 problems, 3 and 4. We're going to focus just on 3. Then we'll summarize, go over some of those important things, and then we'll talk about just problem 4. The directions are this. There are 16 girls and 12 boys in Miss Garcia's class. Think about that situation. Handle each problem individually, working with your group. Online learners, that means you guys are going to be pausing the video, working through these, and only continuing the video once you've answered all parts A, B, C, D, and E. If you get stuck, please go back and watch the last video or refer to the practice problems we did previously. Those can be a really good tool to you. The time is now yours. Please get started. Online learners, pause the video. Okay, we spent about 10 minutes working on these problems and now we're back. Let's take a look at the answers. Again, there are 16 girls and 12 boys. I'm going to color code kind of like I did last time. 16 girls, 12 boys in Miss Garcia's class. What is the simplest ratio of girls to boys in Miss Garcia's class? Notice that it says girls to boys. So that means I'm going to write the girls first, 16G for girls, and 12B for boys. Now that I've written that down, talk me through the process. How did we simplify this ratio? What is the simplest ratio? Let's see the hands. Good. Brighton. Four girls to 3 boys. Sounds good. How did you get there? Someone else. Who else got 4 girls to 3 boys? Good. Lots of you. So how did you get there? How did you get to this being the simplest ratio? Good. Leah. 16 divided by 4, because you saw that both 16 and 12 are divisible by 4. So we divide out 4 from each. 16 girls divided by 4 is 4 girls. 12 boys divided by 4 is 3 boys. That is absolutely correct. And I love showing my work this way. I expect you guys to show your work this way. Show me that you divided the top number by 4 and show me that you divided the bottom number by 4. And let's be good students who put a box around the answer. Let's get in that habit, make it nice and easy for me when it comes time for the test. Next question. Is the ratio of girls to boys in Miss Garcia's class a part-to-part ratio or a part-to-whole ratio? Make sure you're able to explain how you know. Good. Alex. Part-to-whole. Why is it a part-to-whole? Part B. Part-to-part or part-to-whole? Do you want to fix it, Alex? Part-to-part? Yeah, it is part-to-part. Who can explain why it's part-to-part? Why is it part-to-part and not part-to-whole? Caden S. Good. It says girls, 2 boys. If it was a part-to-whole, it would probably have to be girls to what? The whole class, right? Or boys to the whole class, which gets us very nicely into part C. What is the ratio of girls to students in her class? What is that ratio? Tell me how you got there. Caleb. This is asking for a part-to-whole ratio. So how do I take that information that we got in the original problem and convert that to a part-to-whole ratio? What would we do? Yes, take the girls, 16, add it with the boys, 12, and that's how I get the total or the whole class number, which is 28 students. And so now when I'm setting up this ratio, I take that information, the girls, which is still 16G, and now I know the total number of students, that's 28. Notice that I'm not just writing the number 28, I'm including the label 28, S for students. And this is correct, but even more correct though, we should probably simplify it. And the reason I want you to simplify it is because I know what's happening in the next problem. And I know that simplifying this ratio now will just help us out for part D. So let's take a second. What do 16 and 28 have in common? Is there a number that I can divide 16 by and a number I can divide 28 by? Good. Lance. We can divide by 2. Let's start with that. So 16 divided by 2. Who found a different number? Good. We'll get there eventually. But I always like taking these baby steps. Anytime we see a baby step, we can take it. They have a 2 in common, and one way I can check that is they're both even numbers. Since they're both even numbers, they're both divisible by 2. 16 divided by 2 is equal to 8 girls. And 28 divided by 2 is equal to 14 students. Is this all the way simplified? No, we can still see that they have something else in common too, right? What do 8 and 14 have in common that we can divide out? Luke, we have a 2 in common, so I'm going to divide by 2. And 8 divided by 2 is equal to 4. 4G for girls. And 14 divided by 2 is equal to 7S for students. So this is the original ratio, yes, but I always like having it be as simple as possible. The simplest ratio is always the best. And now part D, suppose Miss Garcia has a huge class of 63 students at the same ratio as above. How many students would you expect to be boys and girls? Before I start getting hands to answer this question, I want to show you why it's so helpful to simplify that ratio. 16 girls, 28 students. And we're trying to keep this ratio the same so I know it's equal, and now it's a total of 63 students. And the question is this: can you very easily turn a 28 into a 63 through multiplication? Is that an easy thing to do? No. Could you, if I gave you calculators and you were able to work through it that way? Probably yes. But since this is too difficult, it helps if we take that baby step. Oops. Sorry, I'm trying to make the technology work for me, and it's not. I'm just going to erase. Since this is not easy to do, Simplifying it makes it a lot easier because now I have the 4 girls, the 7 students, and when I ask the question this time, how does a 7 turn into a 63? That's a lot easier to answer, isn't it? That's your 3rd grade multiplication fact. So now I'm ready for student answers. How does that 7 change to a 63? What would I need to do? Not enough hands. How does a 7 change to a 63? Jerem. Nope, you're close. It wouldn't be 12. Use it in your calculator. Check and see. What's 7 times 12? Who can help them out? This is a mask check. Masks need to be covering noses. 7 times what is 63? Let's go Kaden M. It would be times 9. Yep. 7 times 9 is 63. So I should do the same thing here with the number on the top. 4 times 9 is equal to 36. Yes? Okay, now, remember we talked about this last time too. This is an abstract answer. Let's make the abstract answer quantitative, and we will answer by saying there would be 36 girls. Does that fully answer the question? No, because it also asks how many would be boys. So if there's going to be 36 girls, how many boys will there be? If you didn't answer that yet, talk with your groups real quick. Should only take you 15 to 20 seconds. How can I figure out how many boys there are? Quick check-in. Ready, set, go. Okay, and now let's come back together. If there's 36 girls, how do I use that information to find out how many boys there are going to be? Zach. Yeah, you got it. Take 63, subtract 36. The total number of students minus the number of girls is going to be equal to the number of boys, and that number is 27. So there would be 36 girls and 27 boys. And last problem, in Mr. Lloyd's class, there are 10 girls and 12 boys. Is this ratio of girls to boys the same as Miss Garcia's class? Gonna go back and start with that original. That original was, I already forgot, 16 to 12? Is that right? 16 girls, 12 boys. And I realize, oh man, this is hard to compare this ratio because how does a 16 change to a 10? How does a 12 change to a 12? Is this the same? Do I need to use a simplified ratio for this problem? Let's see the hands. Allie, why do I need to use a simplified ratio? Yeah, it's not simplified, and we've already done the work to use a simplified ratio. We created that, so why not use it, right? However, who's a lazy mathematician like me? Uh-huh. And if I don't have to do extra work, I don't wanna. Hands down. How does a 12 change to a 12? Times by 1. So if this were the same ratio, I should be able to take the 16, multiply it by 1, and get this number over here. Is that working out? Yeah, 16 times 1 is 10? Didn't think so. So are these the same ratio? Nope. Could you have done it by finding the simplest ratio? Yeah. If you don't have to, why would you though? Okay? Not the same ratio. And now we're going to pause the video again. While we pause the video this time, I need students to answer questions 3, A, B, and C. This time, I'm only going to give 3 minutes. 3 minutes should be enough to answer all these questions. Here's what I'm going to do though. When it says create a model, I suggest just showing your work the same way that we have for these other problems. Don't take your time drawing a double number line or tape diagram. Just show your work with those calculations just because you only get 3 minutes. Your time starts now. Ready, set, go. Online learners, pause the video now to give you that time to work. We'll come back together and go over it. All right, only continue the video past this point if you've answered these 3 questions on your own. Let's go over this as a class now. I have the ratio set up 3 hours to 69 pages, and the first question is saying how many pages per hour would that be? So what I'm doing is I'm saying the 3 hours is for sure changing to 1 hour. So my question to you is this: how does a 3 change to a 1? I'll wait until I see some more hands. How does a 3 change to a 1? Addie? Nope, I don't divide by 2. 3 divided by 2 isn't 1. Any number divided by itself is 1. So 3 divided by 3 would be 1. And since I'm dividing the 3 by 3, I need to divide the 69 by 3. And 69 divided by 3 is equal to, Maston, 23. So in 1 hour, you can read 23 pages. If you maintain the same rate, how many pages can you read in 9 hours? So again, now I'm changing the 3 hours into 9 hours. Do I need the simplified ratio here? No, because can you easily change a 3 into a 9? How do you change a 3 into a 9, Lance? Multiply by 3. So what should I be doing down here with this 69? Multiplying by 3. Good thing you have calculators. When you plug 69 times 3 into your calculator, what do you get, Kate and M? 207. I didn't actually calculate it myself. Is that correct, guys? 207 pages. And now for the final question. See, we're running short on time, so normally I would like us to write this out as a sentence, but I'm running out of time. In 9 hours, we would read 207 pages, and that's good enough for me for right now. How many pages can you read in 2 hours? And for the sake of time, I'm just going to go through this one. Knowing that we need to change a 3 into a 2, can you easily change a 3 into a 2? How? It's not so easy, is it? And that's why using the simplified ratio is best here. Since it's not easy to change a 3 into a 2, we already know that this is the same as 1 hour. Sorry, I'm trying to keep that nice and neat. 1 hour to read 23 pages. And now, can you easily change a 1 hour into 2 hours? That's a much easier question, isn't it? So the 1 changes to a 2 by multiplying by 2. So the 23 multiplied by 2. And 23 times 2 is equal to 46 pages in 2 hours. Ladies and gentlemen, we have now completed this lesson. It took us 3 days, but now you guys are going to be professionals at finding ratios and equivalent ratios and simplifying ratios, especially after you complete your homework. 4.1a homework section. You do need to complete each of those problems for your homework. It is due next class period. Online learners, you can answer these questions online, answer them on paper, and submit a photo. That's it for today. We'll see you next time.